Welcome to Strength of Material lectures by Civil Thinking, and in this class we are going to solve a problem on torsion in shafts. Before I move on, I suggest you to please watch the video lectures on torsion in shafts one by one as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the problem. Now here we have the shear stress in a solid shaft. Okay, we have a solid shaft. Okay, this is a solid shaft. The shearing stress is not to exceed 40 Newton. Okay, so it means the maximum shear stress is 40 Newton per millimeter square, right? When the torque transmitted is to 20,000 Newton meter. Okay, so at this maximum shear stress, the maximum torque, and the maximum torque is denoted with T, right? It is 20 times 10 to power 3 Newton meter. Okay, now determine the minimum diameter of the shaft. Okay, so we have to find diameter. Okay, so the answer is provided here. Okay, this is the answer. Okay, now if you want to try, you can pause this video and try this solving this problem. Okay, and when you have finished, you can replay the video again. Okay, so let us begin. Now we are going to solve this using the equation of torsion. Okay, now we know we have this equation of torsion. Okay, we know tau max divided by r is equal to T by J is equal to C theta divided by, now this is the equation of torsion. Okay, equation of torsion of shafts. Now if you don't know where did this came from, okay, I will provide the link to watch this in the description. You can watch it from there. Okay, now let us put the values. Now we need the answer in mm. Okay, so I will make sure everything is in mm. Okay, now the tau max is already in mm, 40 Newton per mm square, right? Now we have to find the diameter, and we know radius is what? Radius is half of the diameter. Okay, and the torque is what? Now you can see torque is in Newton meter. Okay, so I have to convert it into mm. Now mm is less than meter. Okay, so we have to increase it with 10 to power 3, so it is going to be 20 times 10 to power 3 and 20 and 10 to power 3, right? So it is 20 times 10 to power 6 Newton mm. Okay, so it is 20 times 10 to power 6 Newton mm. Okay, and J, what is J? J is the polar moment of inertia. Okay, now polar moment of inertia of a solid shaft is given by pi r4 divided by 2. Okay, now again, if you don't know where does this come from, okay, this is the polar moment of inertia of a solid shaft. Okay, I will also provide the link to this in the description. Okay, you can also watch it from there. Okay, so but what we need, we need the diameter, so I will place the diameter here in place of the radius. Now we know radius is half of the diameter. Okay, so I can write here pi times d divided by 2 power 4 whole divided by 2. Okay, now I can rearrange these things and then finally get an equation in terms of something, right? But it will take a lot of time. Okay, so I will just put everything in the scientific calculator to find the value of d. Okay, so let me use the calculator. 40 divided by instead of d I will put x by 2 is equal to 20 times 10 to power 6, right, divided by j. What is the value of j? J is pi times d by 2. I will write x. Okay, in place of d whole divided by 2. So I got d to be 136.56, because everything is in mm, so it is also going to be in mm. Okay, so 136.56 or 136.6, right? So let us see, 136.56 mm. Okay, so our answer is correct. Okay, so I hope you understand everything. If you have any doubts, you can comment, and see you in the next class. Thank you.